Hello again, I'm Eli the Computer Guy, over here for Everyman IT. This class is Introduction to Convergence. So Convergence is the latest and greatest and most wonderful thing going on in the technology world. Basically, what Convergence is talking about is that in the bad old days, 5 years ago, most electronic systems were in their own little worlds and did not talk with each other, or did not talk with each other very well. So you would have a telephone system, and you would have a surveillance system, and you would have an access control system, and you would have your computer network, and you would have whatever else. And although these were all electronic networks, although they had electronics devices and may even have programming, they didn't actually talk to each other. They didn't use any of the same networking. So your digital surveillance system would use coax cable or Siamese cable. Your telephone system would use Cat3 cable. Your networking system would use Cat5 or fiber optic cable. Your access control system may just use a little speaker wire or something. So basically, although you had these computerized systems, they all use their own cabling, all use their own programming. If they talked to each other, they didn't really talk to each other very well. So basically what Convergence is all these systems that used to be separate, through the wonders of technology with Microsoft and Cisco and Oracle and all these people, they have started making these systems so that they can use the same networking gear and equipment and cabling. So voice over IP, if you have a voice over IP telephone, that voice over IP telephone now uses Cat5 cabling to connect to the network. It now connects into routers and switches. If you have a digital surveillance system, the megapixel cameras now use Cat5 cabling to connect back to wherever they store the information. Computers, of course, use Cat5 cabling. So now, instead of all of these different types of electronic systems using different ways to connect and communicate, they are all now using the same basic infrastructure to communicate not only to the devices within their little network, but to other devices. So Convergence is a really great thing. In this class, we're going to talk more about it. This is the future. This is the way everything is going for at least the next 5 or 10 years. So it's very important that you understand what's going on. So let me get a couple of things together, and then we're going to go into understanding what Convergence is. Okay, now to understand Convergence, we should understand what the bad old days were actually like. So let's imagine that we have a building here. So this is our building with our 1,000 people or whatnot in it. And down here we have our server room. So in our server room, we have our little, this sucks, our little telephone system down here. We have our computer system. So our computer network down here. And then we also have, our digital surveillance system. So in our server room, we have our telephone system, which was called a PBX. We have our digital surveillance system, which would be called a DVR, a digital video recorder. And then we have our computer server. So all these things are sitting in the server room. Now, out in the building, you have all your desks with all your people sitting at these desks. Now, from here, if you want a telephone at this desk, you have to run a telephone cable. If you want a computer at this desk, you also have to run a computer networking cable. If you want the same at this desk, again, you have to run a telephone cable and a computer networking cable, and the same computer. So every single desk has to have not just a networking cable, but also a telephone cable running to it. Now, if you want to monitor what your people are doing, using your little surveillance cameras, you then have wiring that runs over to your surveillance cameras from your digital video recorder. So as you can see, although all these main systems are sitting in one server room, and although they go out to the rest of the building, they don't really talk to each other. So every single telephone has to run back to the PBX. The PBX is basically a telephone server, I guess you could say. Every single camera has to run back to the DVR, the digital video recorder. Every computer has to run back to the server. Now, again, surveillance cameras use different types of cable than telephones, which use different types of cable than networking. They don't use any of the same networking components. They don't use the same cable. They don't use the same communication systems, etc. So every time you want to add something to one of these little servers, you have to run cable and etc. This is what is called, oops, can you see? Well, let's put it over here. This is what was called silos. So when you start talking about convergence, you may hear something called silos or siloed. And what that means is the telephone system was siloed. So although the telephones went throughout the building, that system did not talk to any other computer systems. So that was a telephone silo. If you had your digital surveillance system, again, although the cabling and the cameras and everything were all throughout the building, that system really didn't talk to any other systems. So it was siloed. And then your computer system, again, it talked to all the computers, but it didn't talk to the telephone systems, it didn't talk to the surveillance systems, etc. So it was siloed. So all of these systems, although they kind of spider web over each other, they never actually connect, and that's silos. So basically, what convergence does is it rips down these silos and allows these different types of systems to use TCP/IP and the normal networking infrastructure. So now, instead of having all the different cables running out of these servers, you can now have the telephone system run into a switch, the security system run into a switch, and the computer system run into a switch. And now one cable can go to this workstation here and provide the computer and the telephone. And you just send another cable over to this person that does the computer and the telephone. And here the computer and the telephone. So now instead of running two cables, you're only running one. If you want to add a little surveillance camera, then you can just connect that surveillance camera into the switch. So now basically everything is using the same networking environment. Now the nice part with this is the big cost savings is, again, running cabling is expensive. All these different types of equipment is expensive. So now that you only have to run one cable to each workstation, that is less expensive. The other thing that's very important with convergence is now, since these systems are all using the same communication standards, they can now start talking to each other. So now your voice over IP system, so where this was a PBX before, now it's a voice over IP server, now it can communicate with your Exchange server. So basically, when you're sitting at your computer and you open up Outlook, you can now go to your Outlook contacts, click on a contact, and actually call straight from the contact sitting in Outlook, because Outlook, which communicates to the Exchange server, can now also connect with your voice over IP server. So this is what convergence does. So it allows all these different systems to not just be cheaper to implement, but they can also now communicate with each other. The digital surveillance system may communicate with the telephone system, but all these systems can communicate with each other, and it makes life a lot easier. And that's really all convergence is. Now, one of the tools and the very useful things that's come about through convergence, we've talked about before in some of the other networking classes, is something called power over Ethernet. So this is where your Ethernet, your network cable, not only provides the network connection to your equipment, but also provides power. So this is very important in this converged network. So like this here was an IQI megapixel camera. So this is a network camera as you can see. You plug this into the network, and then it goes back and it communicates with the DVR, or the network video recorder, actually. So basically, this is sitting up. As people walk through the door, all that information is sent back and recorded somewhere else. Well, the problem, again, back in the bad old days, is not only did you have to run a video cable to one of these cameras, but you also had to run a power cable. Well, the nice thing now is with power over Ethernet, you either use something like this. This is called a power injector, or your switch can provide power over the Cat5 cable to your device. So whether you're dealing with a camera, whether you're dealing with a voice over IP telephone, even some of the little netbooks and little laptop computers can now get their power over the Cat5 network cable. So if you look at this power injector, you see one side has a normal plug, so you can plug the power into it. And then the other side has two network ports. You have the in, so this is the connection that would go to the switch or to the router. And then you have the out. This goes to your little network device. This out has power going to it. So this out provides enough power for this little this megapixel camera. So power over Ethernet is one of the greatest things in this convergence world. Again, all this is where you actually give your network device not just network access, but also power using Cat5 cable. It's just a fabulous thing, especially if you go into digital surveillance systems. It just makes life so much easier. So one of the concepts when you're talking about converged networks, so these are networks where you have the surveillance systems and the voice over IP systems and the computer networks and a whole bunch of stuff running over the same network. One of the concepts that you need to understand is called QoS, or quality of service. And now this is very, 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 very important once you start doing your voice over IP, so you start using your network for telephone communications, etc. What quality of service does on the network is it allows you to prioritize network traffic. So it allows you to say that voice over IP traffic is more important than surveillance camera traffic, which is more important than just email traffic. Now, if you don't have quality of service on your network, if you're not using quality of service, you can have a real problem, because the network will basically allocate resources basically on a first come, first serve basis. So if somebody goes and starts downloading a BitTorrent file, starts downloading the newest Angelina Jolie movie, the network will think that downloading that movie has priority. So, but anybody who tries to get on the phone and talk to somebody else, there's going to be what's called jitter. It's going to be garbled because all of the bandwidth is being used to download that movie versus allow you to talk on the phone. Now, if your networking equipment has quality of service built into it, basically what your networking equipment will do is it will say, oh, look, this telephone conversation is much more important than downloading a movie. So we're going to make sure that the telephone conversation gets through perfectly, and then the movie is down below. So this is a huge thing, especially when dealing with larger networks. Now, if you're dealing with a small network, a 10-person office, frankly, any switch and any router will be fine. You probably don't need to worry about quality of service. Once you start dealing with a 100-person network or a 1,000-person network, all of your equipment should have quality of service built into it. Now, some of this is automated, so some of the cheaper networking equipment you buy will just automatically allocate quality of service depending on whatever is built into it. A lot of the higher end equipment, such as the Cisco equipment, you can actually go in and program quality of service. So you can say, voice over IP traffic immediately gets, 10% of the bandwidth. Surveillance systems get X amount of bandwidth. So you can actually go in and program this. Again, this is a huge thing. If you're going to be running voice over IP and surveillance cameras and everything over one network, make sure your networking equipment is able to do quality of service. Now, ironically, after the network companies and all that came up with quality of service, and more of the larger enterprises were starting to use converged networks, they started to find out that sometimes on very large networks or with very data-intensive applications, quality of service was not good enough. That plain old QoS, you still had networks getting bogged down, and this was not a good thing. So what people have come up with is, instead of simply using quality of service, they have actually now started using parallel networks for the different equipment on their network. So if you have a digital surveillance system, and like I say, a telephone system and a computer system, what they have decided to do is that each of these systems basically get their own networking equipment. So if you go into the IDF, the Intermediate Distribution Facility, we talked about in one of the other classes, in a building, you will see a switch for the surveillance cameras, you will see a switch for the telephone systems, and you will see a switch for the computers. So although they're all using Cat5, TCP/IP networking, they have actually redivided all these devices onto their own networks or onto their own LANs. Now these, then connect down to the MDF, and again, they will have their own core switches and core routers down there, and they don't necessarily talk to each other directly. What they've done is they will then have routers in between these core switches, so if any communication does need to happen, it will go through these routers. The main reason for this is sometimes, like if somebody misconfigures a surveillance camera, it will push through so much data that it will bog down the overall network. Now, if somebody misconfigures this camera and everything is running on the same network, that means your telephone calls get nixed. Your computer communication doesn't work anymore, all because one single camera was misconfigured. Well, by creating parallel networks, what they realized is if you misconfigure one camera, well, that's only going to screw with your surveillance system. It's not going to screw with your telephones and your computers and anything else that is running on the system. So basically, on larger networks, instead of doing simply quality of service, they actually run parallel networks. Now, as we talked about in our switch classes, a lot of times they won't actually have 3 individual switches in the IDF. What you can do is you can have one switch separated into multiple VLANs. So one VLAN will be for surveillance systems, one VLAN will be for telephone systems, and one VLAN will be for the computer systems. This one switch will then connect, and the main core switches, again, will have their own VLANs. So even though these parallel networks are different LANs, you don't actually have to use entirely different switches for them. You can separate these switches into individual VLANs. But basically, this is all parallel networking is. Depending on what you're doing, this can be a really good thing or a pain in the butt. But I do know for a fact, like I say, when I was installing the digital surveillance systems and we started using megapixel cameras, like that one camera I showed you pushes out 5 megapixel images. I mean, high definition, real-time surveillance footage. Well, that is a lot of bandwidth. That is a lot of bandwidth. And so I misconfigured one of these cameras, and like I say, it shut down the entire network because that one single camera was pushing through so much data on the network that nothing else could communicate. So if you're worried about that, again, you can create a parallel network. Everything still uses TCP/IP, everything still uses Cat5 cable, but you separate all your devices out into individual LANs. Now, the next tool that the scientists or engineers are coming up with to alleviate some of this bandwidth problem is actually trying to push what's called pushing the intelligence to the edge of the network. So right now I know cloud computing is the latest and greatest thing, basically using terminals where all the intelligence is sitting in one main server, and then you have a lot of dumb terminals that communicate with that main server. Well, in the converged world, they're actually trying to do the opposite, where they're trying to make the devices on the edge of the network, so either your telephone or your digital camera, whatever it is, they're trying to actually give that more intelligence so that it doesn't have to use so much bandwidth. Because again, like I say, once you start dealing with the enterprise environment, you know, when we're talking about megapixel cameras, I mean, we're not talking about 5 or 6 of these. We're talking about 100 megapixel cameras. So if 100 megapixel cameras are all pushing data at the exact same time, I mean, that's a lot of switches you have to buy, that's a lot of routers you have to buy. I mean, that's a lot of network infrastructure you have to buy, when most of the time those cameras are simply going to be looking at an empty parking lot. You know, so that camera, if it's pushing data all the time and it's looking at an empty parking lot, basically you're paying a lot of money for switches and routers, etc., to look at an empty parking lot. Yeah, that doesn't really make a lot of sense. So what the engineers are doing is, you know, if you have this camera or if you have the telephone or whatever, it's trying to build more intelligence into that device. And so what they're doing now is, in the main server, they can actually program and they can say what they want these when they want these cameras to transmit information. So in the main server, they can say, I want cameras to save information only when there is movement in the picture. So that programming is done here. That gets sent out to this edge device, and now this camera will only transmit video when something is moving through the screen. So instead of always sending video, no matter what, now only when somebody is walking through the screen will it send video. Basically, the reason this is important is because, like I say, they don't want to be sending all the data all the time. This is also being true with the new, like the voice over IP telephones, where they're starting to have more and more intelligence built into the telephone. Because again, remember, if you're dealing with 1,000 or 2,000 or 10,000 telephones, you may not think about the little bit of network traffic that is going on whenever it updates the contact database or such. But when you multiply that out by 10,000 users, little updates to the contact database can end up being a lot of bandwidth. So the more information that telephone can save internally, the less it has to communicate with the main server. So that's a very good thing. But this is what is called, it's pushing the intelligence to the edge. It's a very, very important new part of convergence. And like I say, this is where these IP devices, again, whether they're cameras, whether they're voice over IP telephones, whether there's some kind of access control system, this is where those little devices, they're actually putting in more and more and more intelligence so that they can act without always having to talk to the server. Because like I say, you know, with these cameras and whatnot, there's a lot of data to be pushing through switches. The more data you have to push through a switch, the more expensive switch you have to buy, etc. So the cheaper you can do it, the better. So this is what it's called pushing the intelligence to the edge. So that's the basic class on Introduction to Convergence. Like I say, back in the old days, 5 years ago, all these different computerized systems were in their own silos. So the telephone system only talked to telephones. The surveillance system only talked to surveillance cameras. The computer system, server, only talked to computers. They really did not communicate with each other. I mean, they may have some little backdoor interfaces, but they really didn't talk to each other or use any of the same equipment. Like I say, telephone systems used Cat3 cable, surveillance systems used coax or something called Siamese cable. computer systems obviously use Cat5 cable. So this was a lot of expense because every single system you had to run its own type of cable, its own kind of networking equipment, etc. So what Convergence does is it tries to make all these different computerized systems use the same networking infrastructure. So now your telephone system and your surveillance system and your computer system, they all use Cat5 cable. They all use switches. They all use routers. They all use standard computer networking equipment. So this is a very, very, very important thing, especially now that they're all using the same TCP/IP protocol and networking equipment. They can now talk to each other and really communicate with each other. So like I say, you can now open Outlook, and if you're using a voice over IP telephone system, you can actually launch a call straight from the Outlook contact. So you can open up Outlook, you can look at your contact, you can just click their phone number, and you're on a phone call with them. This is the power of what you can do with these systems. We talked about one of the greatest tools with Convergence now is something called Power over Ethernet. We've talked about this in other classes. This is where your Ethernet cable can now not only connect your device to the network, but it can also feed it power. So like I say, with surveillance cameras or with telephones, you no longer have to run both a Cat5 cable and a power connection for them. It can get powered straight from the Cat5 cable. We talked about QoS, or quality of service. What this does is this is where your networking equipment, so this means your switches and your routers, can prioritize network traffic based on what it is. So voice over IP traffic is a higher priority than, again, surveillance system traffic, which is a higher priority than just normal browsing the web. This is very important. If your equipment does not have QoS built into it, if somebody, like I say, starts downloading a really big movie off of iTunes or BitTorrent, and you go to call a client, when you try to do that call, it won't sound right because all the bandwidth is being used to download that video, and so you don't have enough bandwidth to actually do a phone call. So what quality of service does is it prioritizes, and it says voice over IP traffic is the most important traffic. So this is very important. Now again, once you start getting to larger and larger and larger networks, sometimes quality of service is not enough. This is where it sounds a little ironic, but they've actually gone to creating parallel networks. So although your telephone system still uses Cat5 cable and TCP/IP, and your surveillance system still uses Cat5 cable and TCP/IP, and etc., they actually create their own LANs for those systems. So either this is where everything has its own hardware, so the surveillance system literally has its own switch, the telephone system literally has its own switch, and the computer system network has its own switch. Or you buy the higher end, like I say, the Cisco switches, where you can create individual VLANs on that switch. So sometimes, like I say, they do parallel networks. It's very important, especially, like I say, once you start doing digital surveillance systems. Digital video cameras push an insane amount of data through your network. A single camera that is misconfigured can shut down a local LAN simply because it is shoving through so much data. So this is why sometimes you want to do the parallel networks, especially if you've got a bigger network. Then we talked about pushing the intelligence to the edge. So this is, like I say, cloud computing is all about pushing the intelligence to one main server. Well, in the converged world, where you have all these different pieces of equipment out there, they're actually trying to push the intelligence out to those individual pieces of equipment. So they're trying to make the video cameras smarter. They're trying to make the telephones smarter. The reason is because the more decisions that device can make, the less data has to be transferred over the network. And again, like I say, if you're thinking about 5 cameras or 10 cameras, you may not realize how important this is. But if you're thinking about putting up 100 megapixel video cameras, again, if every single camera is pushing through 5 megapixels every second, that is a lot of bandwidth, which means you have to buy a lot of switches, etc. if you can give that camera enough intelligence so that it only sends back data when it actually has something to tell somebody, that reduces the overall infrastructure cost tremendously. So this was your introduction to convergence. Convergence is, it is what's happening. Like I say, everything is going to voice over IP telephones, surveillance cameras. You can go to newegg.com and buy a $50 network surveillance camera right now. Basically, everything is going to this converged world. It is great. It is wonderful. You just have to be careful about some of these problems. Like I say, if you're dealing with a small office, you can plug in your voice over IP telephones and your computers and maybe a network camera or two into a switch, and you don't have to worry about a lot. It should work. It should be fine. Again, once you start getting to 50 to 100 people, if you don't set up QoS or if you don't set up, a parallel network, etc., you just try to plug all these devices into one switch. The entire network can go down really quick. Yep, and that doesn't make anybody happy. So that was a class, Introduction to Convergence. As you know, I'm Eli the Computer Guy. As always, it was really good to teach this class, and look forward to seeing you at the next one.